Welcome everybody to Getting APIs to Work. Today we say hello to Robin Marx. Hey Robin, how are you doing?
Hello, how are you?
Good, thanks. And Robin is a well-known expert in the HTTP 3 space. So we'll talk about HTTP 3. What does it mean for API designers and developers? And it's something that hopefully influences the way how you design and develop APIs. Robin Marx is a postdoc researcher at the Belgian University in Leuven and has been working on the HTTP stack and QUIC, the underlying protocol. How did you get involved in that, and what's your history in that HTTP 3 space?
Yeah, so I started my PhD in 2015, and that was just like HTTP 2 was just out. And my goal for the PhD was to look at the performance impact of HTTP 2, mainly on web page loading. So not just APIs, but web page loading in general. And that took about 2 years, and then it was kind of done. And it's like, what's the next thing? And then, of course, HTTP 3 and QUIC, they were relatively early on then, but they were starting to get mature enough to actually do some stuff. And so I kind of segued into there. I did my last 2-3 years of the PhD around those. Was able to contribute a lot on the basics there, especially in regard of tooling. I did a lot of tooling for the protocols to test. And so now I'm still continuing research on the protocols as well. Yep.
It's an interesting story. I remember when HTTP 2 started, and I thought about how does it affect API design and development. It was something, okay, it's like it makes things faster because headers are being processed in a different ways, and it makes things better because you can have requests and responses being multiplexed over a single connection. So that's good. And I also remember thinking that, yeah, that still leaves some things that could be better, but that's really hard to do with the underlying protocol stack. So, and then the whole underlying protocol stack basically got ripped out and replaced. So without going into too many details, how would you say, like, what's the biggest difference in terms of, how HTTP 2 kind of re-architected HTTP or the HTTP stack, and how HTTP 3 does it?
Yeah. So maybe we can switch to a diagram that I prepared.
Sure. Let's do that.
Yeah,
there you
there we
go.
go. That kind of shows it, right? And on the left, you have the typical HTTP stack with TLS and TCP below, right? And so, like you said, what changed this time around is not so much the HTTP layer that is actually relatively stable. What actually changed was everything beneath. So we switched from TCP and TLS to UDP and TLS, and then something very special on top, which is called QUIC. Right. So the new QUIC protocol is kind of like a TCP 2.0. It's kind of like a TCP on steroids, let's say. What they did was take everything that we know from TCP and put it inside of a new protocol, and it's pretty much the same as TCP, but with a few key changes that I'll get into later that really make it quite different from TCP. The main change there is here what we call it the streams, right? The stream multiplexing, the support for multiple parallel requests, let's say, request and response pairs that can be active at the same time on one connection. That is something that TCP does not do, that we then added as like a patch with HTTP 2, or we tried to, but there were some problems there. And now QUIC finally solves this by bringing this from the HTTP layer down into the transport layer in the QUIC protocol here. To help with a problem that is often called the head of line blocking problem. Right.
This is such an interesting picture, I think, because it's like being like an old internet dog, so to speak, right? For me, it was always like everything is TCP anyway. It's like UTP is this kind of like freak protocol used for some special cases, and everything else on the internet basically is TCP, and this changes things pretty radically, I think.
This can be seen as the next big evolution, I think, in the internet. The idea is that things will indeed move from TCP to QUIC over time, and that's not just for HTTP. That's the intent for many other application layer protocols in the end as well. That's the intent. We'll see if that happens.
Yeah, we'll see how it happens. But again, like you said, right, it's interesting that it used to be the case that, well, stuff on the internet is either UDP or TCP based, and that kind of doesn't really hold anymore. I mean, okay, QUIC is also UDP based, but kind of QUIC becomes a new foundation to build on.
Yep.
Right.
Yep.
So I think that is really interesting. Now, this is fascinating in itself, and I would love to talk about this in great detail, but we don't do this today. What I want to focus on today actually is more, let's briefly talk about some of the problems that were still present in HTTP 2. So basically the problems, that kind of spawned the HTTP 3 effort. And then let's look at how HTTP addresses that and what that means for API design and development. So let's start with, the problems that HTTP2 kind of wasn't able to fix because of it being still TCP based.
Yep. So there are two main ones, I think, especially for APIs, and that is a slow handshake, a slow connection setup, which I suggest we talk about later. And then the second one is what I just said was the head of line blocking problem, right? And that is, the details are very complex, but I think the basics are relatively simple. And if I have another visualization, imagine that.
Okay, sure.
I hope changes it, right? So what I'm visualizing here is the different colors of different parallel streams or parallel requests. So let's say 3 different API calls that you do and that are active at the same time on a connection. And they're all being, the responses are sent in individual packets. So each square is a different packet in TCP, let's say, or in QUIC. Now, the thing is, in the internet, of course, it's unreliable by default. So there's packet loss. And to deal with packet loss, TCP and QUIC, they retransmit lost data, right? But that takes a while. So packet is lost, and you have to go all the way back to the sender, and it has to retransmit. So that takes a long time. And the main problem, that's the top. So the top 2 are TCP based. If there is a single packet lost, TCP does not know you have A, B, and C on the same connection. TCP does not know this. This was a purely HTTP layer construct, right? So TCP thinks this is all a single byte stream. Everything belongs to the same file. And so if just a single packet was lost here, the third packet, everything else had to wait. Even if all these other packets, right, they don't have red crosses, it means that they actually arrive at the receiver. They can't be processed. They can't be used until this one lost packet actually arrives or is retransmitted, right? And that's what's called head of line blocking. So one packet loss at the head of the line at the start blocks everything behind it, even though that's not necessary. And that's like the core innovation in QUIC, or the change with QUIC, is that QUIC, it does know that there are A, B, and C active on that connection, right? QUIC doesn't know it's an API request or if it's a JavaScript file download or anything like that, of course. It just knows these are 3 different streams. They are fully independent from each other. And so that means if we have packet loss on stream B, in this case B, right? B is lost. C and A, if they keep on coming in without packet loss, they can just continue to be processed, right? So not everything has to wait for a single retransmission to happen if you have multiple parallel things going on at the same time.
Yeah. I love that because it's like so many things in the API, I guess, design space, right? It's like it's also looking at problem cases, right? Multiplexing works great as long as everything works perfectly. Then if you start to have packet losses, right, like multiplexing does show some unfortunate side effects. And then like these problem cases, right, actually mean, well, maybe we should redesign the whole protocol stack. So I just find that fascinating that, even those designs that are kind of almost good enough for the happy path, right? Like in the sad path, they're not really all that great anymore.
Yep.
So you already talked a little bit about how QUIC addresses that by knowing about those individual requests and kind of response streams going back and forth. So if you had to translate that kind of thing into things that matter for API designers and developers, what would that be? Like, what does that change for you as somebody who's kind of just an HTTP user, so to speak?
Yeah, so the rabbit hole goes much deeper. I'm afraid it's like this. This is often said like QUIC is much better for packet loss because of this reason. But the thing is that packet loss is often bursty, so you have multiple packets in a row that get lost. So you can still
Okay.
have packet loss across these different streams. So a typical advice would be now with QUIC you can much more easily send many more requests in parallel, right? And not
Don't
having to
worry
fear
so
for the head
much
of line
about.
blocking problem.
Yeah.
Conceptually, that's true. In practice, maybe not entirely. It'll be better than TCP, but
Okay.
will this change all that much in the end game? Not entirely sure. Right.
Okay.
So this is more like something that I think you can't abuse or use in a very direct way. You can't really change anything in the way you design your APIs to practically make use of that, but you will see the impacts on your let's say P90 or P99 metrics that you have. Your worst case latency, your worst case performance is going to get way better because of this.
Okay, so you, at least for this particular aspect, what you would say is kind of like that doesn't change the design constraints this much, but definitely think about adopting HTTP3 because it will improve just the runtime behavior.
Yep.
Okay.
Exactly.
Any other advice you have for designers and developers?
Yeah, so I think the second main feature that QUIC
Mm-hmm.
does, like I said, this is the head of line blocking problem, but the other one is the much faster connection setup that we now have,
Okay.
and that is something that you can or have to design around, or at least deploy around, so to say. So if you go back to the diagram maybe for a second, so what you had initially is that your TLS, so your security stuff, that runs on top of TCP, and then HTTP runs on top of that. So you have three different layers, and all these layers have to do their own logic independently of each other. And what QUIC does, as shown in the diagram, is it actually puts the TLS stuff inside of the QUIC stuff. They are no longer separate, they're no longer layered, they're fully integrated. And what that means, quite simply, is basically this. So here I compare two TCP cases with the QUIC case, right? And so for TCP, you have everything separate. First, the TCP three-way handshake, and then the TLS session setup, which, depending on the TLS version you use, it's 1 or 2 round trips, and then the HTTP stuff, right? And so for QUIC, this can happen at the same time. So the blue arrow and the black arrow, they can happen at the same time, at the same round trip, and so you save a full round trip.
Okay.
Setting up the connection, so you get your response back, your red response here back a bit earlier, and that's a start. That's already nice, but that's not really something you can again design around. It's just nice to have that. However, then you get a secondary function from this, which is called zero RTT. And I have a second diagram, but keep this one in mind on the right. So you have blue and black, and then red is separate. But if you do zero RTT, here on the right, the blue, the black, and the red are at the same time. A single round trip, and you get basically your full. You can do your request and get a part of the response, not the full response, but a part of the response back in just a single round trip, right? And that is very, very different from TCP, as you can see on the left side. That can also do this function conceptually, but it still needs 2 round trips.
Mm-hmm.
And with QUIC, we can do this in a single one, right? And now the thing is still, this is nice. What this means is that you can, let's say, so Google started the QUIC protocol initially, and they saw very big gains for Google search. And the reason for that is Google search is a heavily cached page. The only thing that does if you start to search after a while, it just sends an API request to get search results, right? And so the connection was probably broken down because it was a while since you visited Google, but they can send these initial requests for your initial search results in the very first round trip and get results back immediately, right? Twice as fast as basically what TCP can do, right? So there's massive gains in that setup because they didn't have to load the full web page and then start to use the API. They use the API immediately. So if you have things like single page apps or just normal apps, things that really rely on the APIs, you can get your data back a lot faster.
So would you say this becomes particularly interesting if you have like user experiences that kind of where the perceived latency by users will be kind of a direct result of the API behavior?
Yep, exactly.
Okay.
So
in particular, if you do like backends for front ends and these kind of things, right? Like where your API specifically is designed for driving a front end, then that okay, good. So that's a very useful takeaway, I think. Like a lot of people are designing those kind of APIs. So, I mean, typically, right, if you're in the API space, what you do is like you design the API, so you own the API and you own the operational side of the server, and you have no control over the client, right? So if you look into this scenario where your typical scenario means you have the API design and you have the server deployment, but you can't really control the clients. How does that setup then translate into like exploiting this extra capabilities of HTTP3?
Yeah, sadly, you will need to be lucky enough to have a client that actually supports these features as well. So the client has to support zero-RTD. It has to send along this request in the first round trip. But after that, the main work is being done on the server.
Okay, but that would mean that if you do it like this, like you now will have, as part of your API documentation, you now will also have to have like these extra part that says you can get some extra some bonus performance out of this API, but only if the client does this and that, right? Okay. So
exactly.
One more thing that I think that I know you are passionate about is server push, right? So server push also is something that may make sense for APIs, and we don't have time to go into a lot of depth about server push, but since it also is a feature of HTTP3, I thought it would make sense to mention, okay, HTTP2.
And 3,
and 3, yeah. I thought it would make sense to mention it at least and talk a little bit about, like, again, for API design and development, what does server push mean if you are in the kind of in the API space?
Yep, exactly. So server push, for those unaware, it basically allows you, if you get a request for resource A, you can already push along resource B as well. So you can be proactive in what you send back to the client, and this conceptually works, but it is now being said as like a bad idea for web performance if you're loading web pages, because you typically don't have a lot of data to send, or that you are allowed to send at the very start of a connection, due to something called congestion control. The details again don't matter. The end result is that server push is being basically removed from Chrome for HTTP2, for example, and it's not really being broadly supported for HTTP3. And I find this very sad, because I think push can be very, very useful for the API use case in particular. Because there, the idea would be that you have a long-running persistent connection, one that has been going for a long time, that has a high congestion window, as they call it, so it can send a lot of data. And so imagine you send an API request to a typical REST API. So like an old school REST API, I should say, that actually has like the links to sub-resources in there, not the fancy joined GraphQL things that I think people are doing right now. So things that have a lot of sub-resources. And so what you can do is you get the API request at the server. You can look at the response. You could say, okay, they're probably going to need this and this and this sub-resource anyway. why not just push it along with the initial response and having to bypass all the back and forth between the two? And I still think that is a hugely a powerful optimization that you can do for the API use case. And so maybe that's not longer possible for the browsers, but maybe if you have like a custom client, a native app or something like that, I would definitely look into using server push for improving that kind of API. APIs with a lot of sub resources that it's predictable what they are going to need. I think you could save a lot of round trips that way.
So that once again probably then applies to backend for front ends and these kind of designs where you have specific APIs that are meant to be used directly by user interfaces. Right?
Yeah, exactly.
Very interesting. So I think it's interesting to look at these changes that HTTP 3 does a lot, like it's inside the protocol stack, but that it still translates into something that matters for API developers and designers. So let's assume you're somebody who's in charge of setting API guidelines, telling teams how to design APIs in organizations. For people in that role, what would you say is the best way to communicate with basically their customers, right? The API designers in the organization. Should they just start talking about HTTP 3 a bit, or like just slightly update the guidelines? Like what would you say would be a good way to take advantage of these upcoming new capabilities that HTTP 3 will give us?
Yeah. So good and bad news there, I think, depending on how you look at it. One thing, I don't think you really need to take two big changes, right? HTTP 3 is very, very similar to HTTP 2, especially in terms of semantics. The headers, they're all very much the same. HTTP 3 still has what you referred to at the beginning, a header compression. So your headers are still as optimized as with HTTP 2, so you can still include longer values in the headers, they will be compressed, that kind of stuff. So you don't really need to change anything at a high level API. You don't need to change design guidelines, anything. You won't have separate HTTP 2 versus HTTP 3 APIs. That will not be necessary. What HTTP 3 and QUIC will mostly be here is probably progressive enhancements, right? Knowing that you run on this, you can be a bit more lax with, as we said before, a bit more parallel requests. Or if you have many very short responses, then it can be very useful to do the HTTP 3 setup with the faster connection setup, because then you will benefit from a few saved RTTs. The same with push, right? So it will mainly be something like extra on top that you can use, but it will require some serious technical know-how, technical expertise to be able to use this to their full advantage. This is something we saw with HTTP 2 a lot. A lot of implementations were buggy. People were using them badly. If you've ever heard about HTTP 2 prioritization and how that matters, you will know that is a snake pit. Exactly because of that, people started using it without knowing exactly what it did. And HTTP 3 made that a bit easier, those aspects, but it's still not like a magic bullet. It doesn't immediately change everything. It's still, as I like to say, it's an evolution, not a revolution.
Yeah. But it's
So
it's a good point, right? It's a new tool, I think, right? And like all tools, right? You can either ignore it, or you can use it well, or you can use it badly. And I think most importantly, right, we'd like to make sure that people, at the very least, don't use it badly. So
exactly.
maybe one last thing we could do to finish this is, could you imagine a scenario where people would use it badly? Is that something, HTTP 3, is that something you've already encountered, or is that something where you say, at least in HTTP 2, like these risks, let's say, were a little bit bigger, and in HTTP 3 it won't be such a big problem?
then we have to go back to the visualizations. Yeah,
Let's
there we
do
go.
that.
So this is the prioritization stuff that I talked about, right?
Yeah.
So it really depends on how you use the resources and how they are coming in. So here again, we have A, B, and C, right? And A, B, and C, like a lot of times people say on HTTP 2 and 3, things can be transported in parallel. But that's not really true. They're not actually being sent in parallel, they're just being multiplexed. So you can cut them up into smaller pieces and as it says here, multiplexing, so put them in certain order, but it's not really parallel. And the way you multiplex them, the order you choose, that really matters. Like here, for example, in this one, let's say A, B, and C can only be used if they are fully downloaded, right? Like I said, you're not streaming them, you're not streaming or interpreting the response as they come in. You wait until it's fully done and then you read it. If you then choose the top option, well, you can see it takes a long time for everything to be ready.
Yeah.
Right. Well, if you choose the bottom option, you can already use A and B much earlier than the other one. Right. And so that is a very powerful foot gun. This is being the ordering here is being decided by the prioritization system, like I said before. And so this was very difficult to do in HTTP2, and it was very difficult to implement. And so a lot of servers had bugs that even if you asked the bottom one, you would still get the top one.
Oh,
Right?
okay.
So
Yeah.
you would still be very bad. And the nice thing about HTTP3 is that's a big change, that this system has been changed. So now you can identify priorities by using HTTP headers. HTTP2 that was in a deeper layer of the stack. You had to use APIs that you couldn't even use from the browser side directly. HTTP3 changes that now because they noticed, okay, this is way too difficult, and so they changed this to be HTTP header driven. So now it's just a header. You do a request and you indicate in the header, this is the priority, or it's called urgency of the request, and this is how I want it to be handled. Right. So the API there, the interface is much easier to drive this, and we hope this also makes the implementations less buggy. So that you can very well indicate which of these or anything in between, because there
Yeah.
are many other options, which you like. And so it depends on which type of responses you have. If you have, let's say, a lot of text-based responses there, but you're also intermingling this with images, right? Image responses, let's say you're loading a Facebook feed or something, many different things are loaded at the same time. You can very fine-grainedly start to indicate this is first, should be processed in that way, this is second, this should be done that way. You could conceptually do that with HTTP2, but like I said, many big problems there. We hope this changes with HTTP3.
That
We
is
hope.
really interesting. It's like so that basically lifts up this kind of control to the point where an HTTP API designer has control over it, right? And they didn't have control over it before. So I think that
At least not in the browsers.
Yeah.
Exactly.
Okay. So as we see, there's still it's not like you said, it's not the silver bullet, but it's a good new tool that people have in their toolbox. Okay, any closing words you would like to have, Robin?
Only again, this is like what are we up to now? 25 minutes or something like talk. That's only barely scratching the surface, right? And I have several more in-depth blog posts and YouTube videos and all kind of stuff, and also my Twitter account that goes into a lot more detail about these things. So if you want to know more and how to actually practically use this, please visit them. If you don't, that's fine too. Just keep in mind, HTTP3 and QUIC, very nice new things. You're not missing out on much if you don't switch immediately, but it's a good idea to keep this in mind and maybe try to deploy it for some things, especially if you're using CDNs, content delivery networks, or serverless providers. They often already have support, so you can start trying it out and see if it might make sense for your use case. But you have time. You're not missing out. You're not missing the boat if you don't switch immediately. Yeah.
Okay, great, thanks. And yes, I would like to encourage everybody to check out Robin's resources. I'll link everything from the video description so that you can easily find it. And if you're interested in in kind of any level of detail about HTTP3, Robin, I think really is a great resource. Thank you so much for joining and giving us this brief kind of brief introduction. We tried to keep it short, but at least it's kind of short. And I think it is something that will, I mean, it will influence the web and APIs for a very long time. So it is really interesting to look at it. Thanks for joining. Thanks for taking the time. And well, if anybody's interested in more details, let us know. And we might just have a couple more videos about all these interesting features of HTTP3.
Right. Bye.
Okay. Bye, everybody.